Alright, so this video is page 74, Geometry 2. The volume notes are going to be continued on. I'm going to give you another example to help you with studying volume formula forwards, backwards, and for things you're going to see on your test. So what if I give you a volume and I say it's 300 inches cubed? I give you a height, and I say the height is 10 inches. What could your length and width both be to make this work? And we have to think about the volume formula. We know that if you take length times width times height, that's how we get volume. So if we write the volume equals length times width times height, I really think writing the formula out and then filling in the blanks is really helpful. So do we know our volume? Do we know our length? Do we know our width? Do we know our height? Fill in what you know, and that will help you figure out how you can solve the others. We know the volume was 300, so that's under V. We don't know length or width, but we know the height is 10. So we're looking to find length and width. Again, when we were solving equations, you do the opposite to solve for variables. So we know length times width times height have to get. So instead of trying to just plug random numbers in here and take it times 10 to get that answer, if you divide by 10, it cancels on this side. Whatever you do to one side, you have to do to the other. So if you divide by 10 over here, now this side, instead of being 300, is 30. In other words, we're still trying to figure out my length times width. I don't have those. So what could my length and width be to give me 30? There's more than one thing that could have a length and width to give us 30. There's several examples that would give us 30 for a length times a width. They're not all the exact same, but some of them you could say 2 times 15. You could say 1 times 30, 3 times 10. There's another one that would give you 30. You could say 5 times 6. I didn't mean to make that look like a decimal. That's a line. 5 times 6. Those are all ways to give us 30. So what would it look like if I have to put my length and width and draw it out? Well, I would have to connect 2 cubes together and then go 15 cubes wide like this for 2 times 15. 2 times 15 to give me 30 cubes hooked together there for my area. If I drew a 1 by 30, it's a little narrower. Instead of 15, it's got to go out 30, so it's like double the length of that one. 1 cube by 30 still gives me an area of 30. It's just a longer rectangular base. If I do 3 by 10, then I connect 3 cubes going down and then 10 going this way. 3 by 10 still gives me a base of 30. A 5 by 6 is almost a square base. It's not 5 by 5 or 6 by 6. It's almost square. It's a little bit of a rectangle. 5 by 6. So 5 by 6 is another way to get 30. So all of these bases have 30 cubes in them when you're hooking them together. And I have those for you to see here at school, but to see what the bases are. Their heights would all be 10. They would all be the same height going up, but their bases look very different. So some more help with that. To help with volume, we're going to do another homework worksheet on volume. This volume worksheet is actually the Common Core worksheet. I would like you to do evens from both sides. You can use your calculator, but show your work. So these notes will be helpful to study for your test. The only difference between my notes and what you're going to see for your homework is a lot of the dimensions for your homework, instead of being whole numbers like 5 and 6, they're going to be like fractional side lengths. So you may have 1/4 as a side length or 1/2. You may have some whole numbers, but you're also going to have some fractional side lengths.